Greetings, Freedom High School chemistry students. Today we are going to do some half-life calculations. Now you remember half-life is the time it takes for half of a radioactive sample to decay. We're going to use this formula that the amount remaining, the amount still radioactive, is equal to the original amount divided by 2 to the n, where n is the number of half-lives that have gone by. And how we figure out the number of half-lives that have gone by, you take the total time that has passed and divide it by the half-life of that particular substance. Now this is a good time to go ahead and get out your reference table that I know you guys all got and go to the second page, the formula page, and at the bottom we're going to add the formula for half-life calculations. So you should pause right here and put that on your formula sheet. So let's do a problem. We're going to do an example problem, and we're going to see how we do these type of problems. So here's our first example. Now, as a review of what we learned already, we could look at a decay chart, and if we found we had a sample and we found that 50% of the sample was still radioactive, well, we could go into our chart and go over to our curve and go down, and we would find, well, that sample would be 5,730 years old. If we had a sample of, this is carbon 12, actually carbon 14, if 25% of the carbon 14 was still radioactive, was still carbon 14, we would go over to our chart where you hit your trend line and go down. We'd find that about 11,000 years old. So this is an exponential function, and we can actually use a mathematical formula to do this. Now in Math 3, you're going to use one that you could use for any amount of time, but we're going to simplify it a little bit and use only for a whole number of half-lives. We're just trying to get the idea, not necessarily get tripped up by the math. So our first step is identify what's given in the problem. So an isotope has a half-life of 6 hours. So that would be our T1 half, the half-life of the substance. What percentage will be left after 24 hours? So 24 hours is our total time, T total. And the question is asking us what percentage will be left. Well, that means the amount remaining. This is amount remaining. Now the trick is with the percentage problem, if they're asking us what percentage is left, well, that means we're always starting with 100%. So let's go with our formula. Actually, I always figure out how many half-lives passed first, if I can. The number of half-lives, n, which is the total time, T total divided by total, let's put a total there, divided by T1 half. I have 24 hours divided by 6 hours. That would be 4 half-lives have passed. So to me, that means 4 half-lives means we had an original sample which was divided in half once, twice, 3 times, and 4 times. That original sample was divided in half 4 times. That's what's left. So let's work this out. Amount remaining is equal to the original amount, which is, in this case, will be 100%. You're always going to start with 100% if we're doing percentages, divided by 2 to the number of half-lives, which is 4. which is what this is saying. It's taking the original amount and it's dividing it by 2 4 times. We can do it kind of in our head or in the calculator. We'll do both. 100% divided by 2 once is 50%. 2 twice is 25%. 2 3 times is 12.5%. And divided by 2 4 times is 6.25%. Let's put it down here and let's verify with the calculator. We got this calculator, and whoops, I already did it. 100 divided by 2 to the 4th, 6.25, verified. Let's do another example problem. So first step is always to read it and to identify what is given. What is given in here is the half-life of gold 198 is 2.69 days. So that is my T1 half. If 2 grams is left, look at that, 2 grams is left. That means this 2 grams is our amount remaining. That is what is left after a certain amount of time. Well, that would be our T total. How many grams were in the original sample? So this time we're looking for the original sample. Pretty good. So first thing we're going to do is figure out how many half-lives have passed. T total divided by T1 half. 8.07 divided by 2.69. Days. The days cancel out. We are just left with a number. It's 3 half-lives. HL for half-lives. Pretty sweet. Now, if we go back to our original formula, we have amount remaining is the original amount divided by 2 to the n. Well, this time we are looking for original amount. So our one-step algebra equation is I'm going to multiply both sides by 2 to the n. And if you need to review that algebra, then you go back and review it, but that's a prerequisite for chemistry. So my original amount is what I'm solving for. And if I multiply both sides by 2 to the n, the amount remaining, and that's going to be times 2 to the n, which is 3. So what this is saying, the original amount is how much was left, times 2 3 times, times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16 grams is what was the original amount. And I can double check myself. 16 grams, 3 half-lives passed. After 1 half-life, you'd have 8 grams left. That's the time it takes for half to decay. Another half-life, that 8 grams would be reduced to 4. And after 3 half-lives, 1, 2, 3, it'll be reduced down to 2 grams. So I can double check my problem. I hope this helps. This is the approach you should use on all the problems that we have. Let me know if you have any questions.